Welcome to tonight's video on how to solve systems of equations with the conic sections. First of all, we're going to talk about how to find the number of real solutions a system has without solving it. So the first thing you want to do is determine what equation you're looking at. So for example, x squared plus y squared equals 25. That is a circle. You can tell it's a circle if it's number one, addition. Number two, the numbers in front of the squareds are the same. If it's not the same, like for example, if it was 3x squared plus y squared equals 25, then it would be an ellipse. And if it's minus in the middle, x squared minus y squared, then it would be a hyperbola. The second equation is a line, because it's just y equals mx plus b. It's 2x minus y equals 2. So for the circle, when you graph it, you go up 5, you go up 5, over 5, down 5, and to the left 5, and then you make your circle. So this is a circle. And the center is 0, 0. For the line, I would put it in y equals mx plus b form. So I'd go 2x minus 2 equals y. So you know your slope, your y-intercept is -2, and you go up 2 over 1, up 2 over 1, and you draw your line. And you count how many places it intersects. If you notice it intersects in 1, 2 places, so that means there are 2 real solutions. If you look at the next one, this is a hyperbola, and this is an ellipse. So hyperbola, notice, remember it should equal 1, so you divide by 16, but since it's minus, that's how you know it's a hyperbola. So it's x squared over 16 minus y squared over 16 equals 1. So since x squared is first, you know it is a horizontal hyperbola. So you go to the left 4, to the right 4, and you have the hyperbola. It looks something like that. Remember, we're drawing rough sketches. We're not putting the focus and all that stuff in. For the ellipse, this is a horizontal ellipse. So you're going to go over 3, up 2, and you draw your ellipse. And you see how many times it intersects. Well, you notice it does not intersect. So if it does not intersect, that means there is no real solution. All right, so the next part, it actually asks you to solve the equations. And to solve the system of equations, first of all, if you don't have them both squared, for example, here you have a hyperbola and a line. But notice this has x squared, y squared. This just has x and y. So if you have a line, you're going to have to do substitution. So you're going to have to solve for one of the variables in the line. So since it's just x here, I'm going to make it x plus 6y equal 3. Subtract the 6y. So x equals 3 minus 6y. So then you're going to take this 3 minus 6y and you're going to substitute it in for x in the top one. So it's going to be 3 minus 6y squared minus 9y squared equals 9. So then this means you're going to FOIL. So 3 minus 6y, 3 minus 6y. So that gives you 9 minus 27y plus 36y squared minus 9y squared equals 9. So 36 minus 9 is 27y squared minus 27y, and then equals 0. Sorry, it should be 36y here because it's 18 and 18, so it's minus 36y. So this should be a minus 36y here, and this should be 27y squared equals 0 when you subtract the 9 from both sides. So to factor it, you take out the common factor, which is 9y, and you have 3y minus 4 equals 0. So setting them both equal to 0, you get y equals 0. And then y equals 4/3. So now you have two scenarios. If y equals 0, so you put that 0 in here, so it's x equals 3 minus 6 times 0. So x equals 3. So one answer is x is 3, y is 0. And the other one, if y equals 4/3, so you go x equals 3 minus 6 times 4/3. Notice it goes in twice. So x equals 3 minus 8. So x equals -5. So it's -5 and 4/3. So these are your two answers, your two solutions. Now, if they're all squareds, so here's an example of where you would do elimination. Now when I eliminate, I like to add. So I'm going to multiply by the opposite to be able to eliminate. So if I want to eliminate the x's, I'm going to multiply the top one by -4. So you get -4x squared minus 4y squared equals -28. And the bottom one will stay the same. So I'm going to add down. So notice eliminates the x's. So I get -y squared equals -4. Divide by -1. Y squared equals 4. And now here's the part where people can make a lot of mistakes. When you take the square root, you get y equals plus or minus 2. So that means there's two answers for y, and you can solve it in the equation both ways. So if y equals 2, then x squared plus y squared equals 7. So x squared plus 4 equals 7, x squared equals 3, x equals plus or minus rad 3. So there are two answers for when y is 2. You get positive square root of 3 and 2, and negative square root of 3 and 2. And then if y is -2, you do the same thing. So you solve. So x is equal to plus or minus rad 3. So that means it's also negative rad 3 and -2, and positive rad 3 and -2. So there are 4 answers to this question. There are 4 places of intersection. Now, if you look at number 6, you can eliminate by either multiplying the top by -2 to eliminate the x's, but I'll do something different. I'll multiply the bottom by -2 to eliminate the y's. So you get x squared minus 2y squared equals 23. Negative 4x squared plus 2y squared equals negative 2. So when you add down, you get negative 3x squared equals 21. So you get x squared equals negative 7. So you get x equals plus or minus rad negative 7, which means it's imaginary. And if it's imaginary, that means the solution is not real, which means there are no real solutions to this problem. Meaning the graphs won't intersect. All right, the last one here, notice it's first power, so we gotta substitute. So x, y equals 3, and now you just need to solve for one of the variables. So let's solve for the y in terms of x, or actually, we'll do the x in terms of y. So we'll go, x, y equals 3, x equals 3 over y. So we'll put that in, so we get 4 times 3 over y squared minus y squared equals 5. So you get 4 times 9 over y squared minus y squared equals 5. 4 times 9 is 36. So now you got to get rid of the fraction, so you got to multiply by y squared. So when you do that, you get 36 minus y to the 4th equals 5y squared. And so now you want to bring everything over to one side to see if you can factor. So subtract the 36, subtract the y, or add the y to the 4th. So you get y to the 4th plus 5y squared minus 36. So this is a form of a quadratic. You can go y squared plus 9 and y squared minus 5, and that equals 0. Now you can't factor either one of these, so if you solve, y squared plus 9 equals 0. Y squared equals negative 9, so that means there's no solutions there. Y squared minus 5 equals 0. Y squared equals 5. So y equals plus or minus rad 5. So if y equals rad 5, then remember back here, x equals 3 over y. Sorry here, this should be a 4. That's why this wasn't working out too well for me. When you factor, it should be y squared minus 4. So y squared minus 4 equals 0. Y equals squared equals 4. So y equals plus or minus 2. So coming back up here, if y equals 2, then x equals 3 halves. And if y equals negative 2, then x equals 3 over negative 2, which is negative 3 halves. So it's 3 halves, 2, 3 halves, negative 3 halves, negative 2. Those are your two answers. All right, hope this has helped, and have a good evening.